This is 6.1, multiplying fractions and a whole number. So how can you model the multiplication of a fraction and a whole number? Multiplication can be expressed as a repeated addition. So we know that 3 times 2 is 3 plus 3, or 2 times 2 times 2. So there's 3 2's. So in this example, we have 3 times 1/2 right here. So we have 1/2 plus 1/2 plus 1/2 added up. We know that from basic addition, 1/2 plus 1/2 plus 1/2 equals 1 1/2. So we can see that down here when we model it with trapezoids. We've got half a trapezoid right here, half a trapezoid right here, and half a trapezoid right here. When we add it up, we have a full trapezoid plus one more. The yellow hexagon represents one whole. This would be 1. This is for future. 1. The yellow equals 1. Red equals half. And blue equals 1/3. The green triangle equals 1/6 of a hexagon. As you can see here, 1, 2, 3, 4, 5, 6. There's 6 different parts. So how does the diagram of the rectangle model the same addition? So we've got 1/2 here, and then 1/2 plus 1/2. So when we add them all up and we fill this in, we've got 1 full half plus 1 more left over. So 1 full, and 1/2. So we've got 1 plus 1/2. This is nothing, and that's nothing as well. So we've got 3 times 1/2 equals 1/2. Model 4 times 1/6 using the pattern block. So in A, we can see that 4 times 1/6 down here. We've got 4 of the 1/6 triangles. So there's 1, 2, 3, 4. Remember that the green ones, the green triangles equal 1/6. So we add them all up. 1, 2, 3, 4. And we've got this much of the hexagon, which equals 4/6. So model the same multiplication using the diagram of the rectangles. We've got 1/6, 1 out of 1, 2, 3, 4, 5, and 6. And we add that up. 1 plus 2 plus 3 plus 4. So 1 plus 1 plus 1 plus 1 equals 4 out of 6. And when we put this to lowest common terms, it equals 2/3. The final one, copy and complete the multiplication statement. 4 times 1/6 equals 4/6. We can put this as a 1 as well. 4 times 1 equals 4, and 1 times 6 equals 6. We know that we can put this in lowest common terms by dividing each one, in this instance, by 2. 2/3. Or 2/3 is the full answer. So we need to model 2 times 4/3 using the method of your choice. So we can use squares, or we can use the hexagons. I'm going to use the hexagons because it's here. We've got one hexagon there plus 1/3 right there. So we're going to use a second hexagon down here. When we add these two up, we get 2 hexagons plus, when we'll rotate this so you can see that it makes up the hexagon, plus, it equals 2 2/3 of a hexagon. So here's 1, here's 2, and there's 2/3 of a hexagon. Copy and complete the multiplication statement. 2/1 times 4/3. And we can check this, and it's 8/3. We know that 3 goes into 8 2 times, leaving remainder 2/3. So the answer, 2 2/3, which is what we found up here. Multiply using manipulatives. So this is an example. Determine 3 times 5 over 6 and express the product in lowest terms. So we've got the solution right here. We know it's 5 plus 5 plus 5 over 6 because it's repeated addition. That's all multiplication is. When we model the fraction using fraction strips, or sorry, using the squares, we have 5 out of 6, 5 out of 6, 5 out of 6. When we add that up, there's 1, there's another 5 to here. So there's the second 5, and then there's the third 5, leaving 3 left over. Count the shaded parts. Each part represents a strip, so 2, 1 and 2, big 2, and 3 over 6, because we have 3 over 6 here. We know that this is a whole because it's full. 1 and 2. You could model with pattern blocks instead of fraction strips as well. We could use this, we could use that, we could use this. We could write the product in lowest terms. So we know it's 2 and 3/6, or if we counted them all up, it would be 15 over 6. So write the product in lowest terms, 15 over 6 right here. We get 5 over 2, which then equals 2 and 1/2. Because when we divide 5 by 2, we get 2 with a remainder of 1, which we then put back over the fraction of 2. Example 2, multiply using diagrams. Determine 3 times 2/5. So 2/5 plus 2/5 plus 2/5. There's 3 of them because we times it by 3. Model the fraction using a number line. So when we take a number line, we split this into 1, 2, 3, 4, 5 different parts. And we continue to do that each number because we're multiplying by fifths. So we move by 2/5. So 1, 2 is the first one. We do this 3 times. There's the second. There's the third. We know that this is 1. So we have 1 and 1/5. So 6, 1, 2, 3, 4, 5, 6 adds up to 6/5, or we can count by 1 and 1/5. Apply multiplication with fractions. A spider has 8 legs. An ant has 3/4 as many legs as a spider. How many legs does an ant have? So in math, the word of often indicates multiplications. So when we say, that's just an aside, an ant has 3/4 of the numbers of the legs that spider has. 3/4 of 8. And 8, of course, can always be represented as 1. We can use this on a number line down here. We can use it with fraction blocks or strips, or we can just do straight multiplication. We know that 3 times 8 equals 24 over 4. 24 over 4, 24 divided by 4 would be 6. The result is 6. The ant has 6 legs. So your homework is the 200 both show you knows and then 201 show you know.